Hello guys, Assalamu alaikum, Bismillahir Rahmanir Rahim. So far we have done exercise 1.1 and 1.2. Today we'll discuss exercise 1.3. In this exercise we will discuss addition and subtraction of matrices, some properties of matrices like commutative property of matrices, associative property of addition of matrices, and identity of matrices, inverse of matrices, and then we will see how to multiply a matrix by a scalar number. So let's start addition and subtraction of matrices. Two matrices A and B are conformable for addition or subtraction if their order is same. Let's say there is a matrix A 1 2 3 4 5 6 and there is a matrix B whose elements are 5 6 0 7 8 3. You can see what is the order of A. Order of A is 2 rows and 3 columns, 2 into 3. And what is the order of B? The order of B is also same, 2 into 3. 2 rows and 3 columns. You can see 2 rows and 3 columns. Of A also 2 rows and 3 columns. Since the order is same, so these two matrices are conformable for addition or subtraction. But if you will see this A, let's take 1 2 3 4 5 6, and if B is having elements 1 2 3 4 5 6 like this, what is the order of A? Order of A is 2 into 3, whereas the order of B is 3 into 2, 3 rows and 2 columns. Since the order of A and B now it's not same, addition or subtraction is not possible in this case because order is not same. So we cannot find A plus B or A minus B. So what is the condition for addition or subtraction of matrices? Order must be same. Now we will see how to add or subtract two matrices. For example, we have matrix A whose order is 2 into 3 and B is also given whose order is 2 into 3. So how to add these two matrices? So A plus B is equals to, addition of two matrices is denoted by A plus B. First write matrix A 1 2 3 4 5 6 plus sign because here we have plus. Now write matrix B 7 8 9 0 1 2, for example. B is given this one. Now what will be the addition A plus B? How we will add? We have to add the corresponding elements of A and B. So 1 plus 7, you can write here 1 plus 7, 2 plus 8, 2 plus 8, you will write at the same position. For example, this 3 is the element of first row and third column. And you have to add 9, 3 plus 9, 9 is also first row and third column element. So here also we are writing 3 plus 9 at the place of the first row and third column. Similarly 4 plus 0, 5 plus 1, 6 plus 2. Now you can see 7 plus 1 is 8, 8 plus 2 is 10, 9 plus 3 is 12, 4 plus 0 is 4, 5 plus 1 is 6, 6 plus 2 is 8. So this is called addition of matrices. Now see the order of A plus B. The order of A plus B is also 3. So you can see order will not change. We have the order of A and B is 2 plus 3. So order of A plus B also will be same. So order will not change after getting addition. Similarly, we will see how to subtract two matrices. This time I have taken 3 by 3 order. So A minus B. So first write metric A. 2, 4, 6, 8, 10, 12, 14, 16, 18. I have taken even numbers. You can also take the same example. Now B, I have taken odd numbers 1, 3, 5, 7, 9, 11, 13, 15 and 17. Now how we will do A minus B? So similarly, like addition, you will do subtraction also. 2 minus 1, you can write here. 4 minus 3, 6 minus 5, similarly 8 minus 7, 10 minus 9, 12 minus 11, 14 minus 13, 16 minus 15 and 18 minus 17. You can do direct also, but for the sake of convenience I am writing this one. So 2 minus 1, 1, 4 minus 3 is 1, 6 minus 5 is 1. So all you will get 1, 1, 1. So you can see the order of this A minus B, which is same, 3 into 3. The order of A and B was also 3 into 3. So this is how we will do addition and subtraction of matrices. Next is commutative law of addition. If A and B are two matrices of the same order, then commutative law says that A plus B is equals to B plus A. This is called commutative law of addition of matrices. But it is not valid for A minus B is equals to B minus A. This is not possible. A minus B will not be equal to B minus A. Only A plus B will be equals to B plus A. That's why they said commutative law of addition. So if A and B are two matrices of the same order, then A plus B equals to B plus A is called commutative law of addition. Next is, this is number 1. Number 2, these are, you can say these are the properties of matrices. Next is associative law of addition. In associative law, we must have three matrices of the same order. So say A, B and C are three matrices of the same order. Then A plus B plus C is equals to A plus B plus C. What does this mean? It's mean first if you add A plus B and then C will be equals to if you add B plus C and then A, you will get the same answer. So it doesn't matter if you add A plus B or B plus C. Associative law holds for the addition of matrices. Next is, let's see the example. For the same matrices, first I will prove commutative law and then I will prove associative law. For example, A plus B is equals to, first you need to check the order. So the order of A is 2 into 3. Order of B is also 2 into 3. C is 2 into 3. So they are conformable for addition. So what is A plus B? 1 plus 6, I am writing direct, 7. 2 plus 5, 7. 3 plus 4, 7. 4 plus 3, again 7 here. 5 plus 2, 7. And 6 plus 1 is also 7. So this is A plus B. If you do B plus A, then what you will get? Let me write here. B plus A means 6 plus 1 is 7. 5 plus 2 is 7. 4 plus 3 is 7, 3 plus 4, 7, 2 plus 5, 7, and 1 plus 6 also 7. And the order is also same. You can see A plus B is equals to B plus A. A plus B is equals to B plus A. So this is called commutative law of addition. Now let's see associative law of addition. In associative, you must need A plus B plus C. You can see A plus B. First add these two plus C. So what is the answer of A plus B? A plus B is 7, 7, 7, 7, 7, 7. What is C? C we have 0, 1, 2, 3, 4, 0. So if you will add these two, what you will get? 7 plus 0 is 7, 7 plus 1 is 8, and 7 plus 2 is 9. Similarly, 7 plus 3 is 10, 7 plus 4 is 11, and 7 plus 0 is 7. So you got this metric. Now if you do A plus and B plus C, so first write the element of A. A is 1, 2, 3, 4, 5, 6, plus what is B plus C? B plus C will be 6 plus 0, which is 6, 5 plus 1, 6, 4 plus 2, 6, and 3 plus 3, 6, 2 plus 4, 6, and 1 plus 0 is 1. This is what we got, B plus C. Now if you add A, so 6 plus 1, 7, 6 plus 2, 8, and 3 plus 6 is 9. 4 plus 6, 10, 5 plus 6, 11, and 6 plus 1 is 7, which is same. These two are same. So this is called associative law of addition of matrices. So A plus B plus C is equals to A plus B plus C. Both will be same, both will be equal. So commutative law also we have proved with the help of example. A plus B is equals to B plus A. This is called commutative law, and associative law also we have proved. Now next is additive identity of matrix. Additive identity. For example, in real number you have 0 is the additive identity. If you add 0 in any number, for example 100 plus 0 is also, you will get 100. So 0 is the additive identity. If you add 0 in any number, you will get the same number. For any real number, x belongs to R, any real number, x plus 0 is equals to x. This is called additive identity. 0 is called the additive identity. So here in matrices, null matrix. Null matrix is the additive identity. What is null matrix? Is represented by O, 0, 0, 0, 0, 0, 0. All elements are 0. That is called null matrix. We have studied before in the last lecture. What is the additive identity of matrices? A plus O is equals to O plus A. Either you add null matrix from left side or from right side. It is commutative. Answer will be A. A plus O or O plus A will be equals to A. This is called additive identity of matrix. So null matrix will be the additive identity of matrix. For example, we have A 1, 2, 3, 4, 2 into 2 order matrix, and we can take O. O is 0, 0, 0, 0. you know, for addition we need same order. So 2 into 2. So what will be A plus O? 1 plus 0, 1, 2 plus 0, 2, 3 plus 0, 3, 4 plus 0, 4, which is equals to A. And if you add O in A, you will get the same thing, which is equals to A. So what is the additive identity of matrix 6? O, null matrix. Null matrix is the additive identity of matrix, of any matrix. So you can write A plus O equals to A, or O plus A is also equals to A. So this is called additive identity. Similarly, additive inverse of a matrix. In real number, if there is a number 2, the inverse of 2 will be minus 2, so that you can get additive identity, which is 0. So just you need to change the sign of the number. 2 is the inverse. 2 is the additive inverse of minus 2, and minus 2 is the additive inverse of 2. Both are inverse of each other. So for any real number, x belongs to real number. If you add x in minus x or minus x in x, you will get additive identity. This is for real numbers. So additive inverse of a matrix means you need to take the negative of a matrix, then it will be inverse of each other. For example, what is the property actually? A plus minus A is equals to O, null matrix. For example, you have a matrix A whose elements are 0, 1, 2, 3, 4, 5. Then take negative of A, which will be 0. No need to write positive or negative. Non-zero elements you need to change the sign. So 0, minus 1, minus 2, minus 3, minus 4, minus 5. This minus A is the additive inverse of A, and A is the additive inverse of minus A. These are the additive inverse of each other. Why? Because when you add these two, you will get null matrix. So how to add? This plus this, 0, 1 minus 1, again 0, and 2 minus 2 will be 0, 3 minus 3 will be 0, 4 minus 4 will be 0, and 5 minus 5 will be 0. So this is a null metric. Next is multiplication of a metric by a real number. So let k be any real number, or you can say any scalar. All real numbers are scalar also. So how we will multiply a metric by a real number? Say for example, A is a metric whose elements are 1, 2, 3, 4, 5, 6, and we need 2 of A. 2 of A means 2 is a scalar number or real number. 2 will multiply with each and every element of the metric A. So 2 will multiply with 1, 2 will multiply with 2, 2 will multiply with 3, 2 with 4, 2 with 5, and 2 with 6. So finally we'll get 2, 4, 6, 8, 5 times 2 is 10, and 6 times 2 is 12. This is 2A. This is called scalar multiplication, or multiplication of a matrix by a real number or by a scalar. This K is a real number. So Ka will be the multiplication of a matrix by a real number. Let's do exercise 1.3. Question number 1. Which of the following matrices are conformable for addition? So you know two matrices are conformable for addition if their order is same. So first of all, write the order of each matrix. So order of A is 2 into 2, 2 rows and 2 columns. Order of B is 2 into 1, 2 rows and 1 column. Order of C is 3 rows and 2 columns. Similarly, you can modify D little. 2 plus 1 is 3 and 3. The order of D is 2 into 1, 2 rows and 1 column. E is 2 order 2 square matrix, 2 rows and 2 columns. Similarly, you can modify F little. 3, 2, 1 plus 1, 2, negative 4, 2 plus 3 is 5 and 2 plus 1 is 3. So you can see here 1, 2, 3, 3 rows and 2 columns. Now you can match the order. If the order is same, then the matrices will be conformable for addition. So the pair A and E having same order, so we can add A and E. So just you need to write which pair of matrices are conformable for addition. So A and E, we can find A plus E. A plus E is possible. Similarly, B is having order 2 into 1 and D is having order 2 into 1. So B is conformable for addition with D. So you can find B plus D. Similarly, C and F. C and F, you can see order is 3 by 2. So C and F you can add both. C plus F is possible. So this is question number 1. Next is question number 2. Find additive inverse of the following matrices. Additive inverse means you need to take the negative of the matrices. So additive inverse of A will be negative A. Just change the sign of all entries of all elements. Plus will become minus, minus will become plus. So plus 2 is minus 2, negative 4, minus 2 will be plus 2 and 1 will be minus 1. So this is called A negative is called the additive inverse of A. Rather, both are additive inverse of each other. A is the additive inverse of minus A and minus A is the additive inverse of A. Why? What is the reason? Because when you add A plus minus A, what you will get? Minus plus 2 and minus 2, 0. 4 minus 4, 0. Minus 2 plus 2, 0. You know corresponding elements we need to add. So 1 and minus 1 will be 0. So you will get null matrix. So when you add two matrices and you will get the answer as null matrix, then these two matrices will be inverse of each other. Similarly, B, what will be minus B? Just change the sign of non-zero elements. Minus 1 will be plus 1. So minus 2, 1, negative 3, minus 3, plus 2 and minus 1. So I change the sign of all elements of B. So this minus B is called the inverse of B, additive inverse of B. So reason is B plus minus B will be equals to minus 1 plus 1 will be 0, 0 plus 0, 0. Again here 0, 2 minus 2, 0, minus 1 plus 1, 0, 3 minus 3, 0, 3 minus 3, 0, minus 2 plus 2, 0, 1 and minus 1, 0. So you will get null matrix. That's why minus B is the additive inverse of B. Reason. C, you can write minus C, negative C is equals to minus 4 plus 2. So C plus minus C is equals to 0 and 0. So you are getting null matrix, so that's why this is the inverse of minus C is the inverse of C. Next, D, E, F. Negative D will be minus 1, 0, 3, 2, minus 2 and minus 1. Just I am changing the signs. Now y, because d plus minus d will be 0 0 0 0 0 0. When you will add all the entries, corresponding entries, you will get 0 0 0 of the same order. Look here, 1 minus 1 0, 0 plus 0, minus 3 plus 3 0, minus 2 plus 2 0, 2 and minus 2 0, 1 and minus 1 0. That's why minus d is the additive inverse of d. Similarly, negative e will be minus 1 0 0 minus 1. Why? Because e plus minus e is equals to null metric. You can verify. So f will be minus f, negative square root of 3, negative 1, plus 1, negative square root of 2. Now f plus minus f is equals to, so square root of 3, positive and negative, when you add both you will get 0. 1 minus 1, when you add you will get 0. Minus 1 plus 1 is 0. Square root of 2, positive and negative, square root of 2, when you add you will get 0. So you will get null matrix. So minus f is the additive inverse of f. Next question, question number 3. If a is this, b is this, c is this, d, then find the value of a plus this matrix. So just you need to replace the value of a here and add this matrix 1 1 1 1 in a. So how we can do this one? Just I am writing here minus 1 plus 1 will be 0. 2 plus 1 is 3. 2 plus 1 3 and 1 plus 1 is 2. You can see because the order is same, order of a is 2 into 2 and this matrix also has order 2 into 2. So that's why we can add easily, and the order of the answer is also 2 into 2. Now here we need to add b. You can see part 2. So minus 1. So 1 minus 2 will be minus 1. Minus 1 plus 3 will be 2. So this is the answer for this one. Here there is no equal sign. This is c plus this one. So what is c? C is 1 plus minus 2 will be minus 1. Minus 1 plus 1 will be 0 and 2 plus 3 will be 5. So this is part 3. Similarly, part 4 is d plus this matrix. The order of d is 2 into 3. And this matrix is also having order 2 into 3. So we can add easily corresponding elements. 1 plus 0 will be 1. 2 plus 1 will be 3. And 0 plus 3 will be 3. And 2 minus 1 will be 1. 0 plus 0 will be 0. And 1 plus 2 will be 3. So this is the answer of part 4. Part 5 is 2a, scalar multiplication. So 2 is multiplying with matrix A. So 2 times what is A? A is minus 1, 2, 2 and 1. So we will get minus 2, 4, 4 and 2. Negative 2 will multiply with each element of matrix A. Minus 1 multiplying with B. Minus 1, what is B? B is 1 and negative 1. So we will get negative 1 plus 1. Minus minus plus. So this is the answer. Now negative of 2c. What is c? C is having one row only, 1, minus 1 and 2. So this will multiply with each element. So minus 2 minus minus plus. Minus 2 times minus 1 is plus 2. and minus 2 times 4, 2 is minus 4. Similarly, we have here 3D, 3 times D. So what is D? Let me change the color. Now 3D, so 3 times D. What is D? D is 1, 2, 3, minus 1, 0 and 2. Just multiply 3, 6, 9, minus 3, 0 and 3 times 2 is 6. So this is 3D. Now 3C. 3C will be 3 times C. C is having only one row, 1, minus 1 and 2. So this will be 3, minus 3 and 6. So that's it. This was question number 3. Now question number 4. Perform the indicated operations and simplify the following. In part 1, 2 matrices. First we will solve these 2 matrices because these are under the parenthesis. Then we will add the next one. So what will happen? So 1 plus 0 will be 1, 0 plus 2 will be 2, 0 plus 3 will be 3, 1 plus 1 will be 1 plus 0 will be 1 plus 1, 1, 1, 0. This matrix I am writing here. Now add these two. 1 plus 1 will be 2, 2 plus 1 will be 3, 3 plus 1 will be 4, 1 plus 0 will be 1. So this is the answer of this one. Similarly, we can add part 3. You see the row. First you need to simplify this one. Here we have brackets, parentheses. So 2, 3, 1 as it is. Order is same, 1 into 3 and 1 into 3. We can subtract. So 1 minus 2 will be minus 1. Here we have plus sign. 0 minus 2 will be minus 2. 2 minus 2 will be 0. Now we can add these two. 2 minus 1 will be 1. 3 minus 2 will be 1. And 1 plus 0 will be 1. Next, part 5. Just you need to add the corresponding elements. 1 plus 1 because the order is same. 3 into 3. This is also 3 into 3. Addition is possible. So 1 plus 1 will be 2. 2 plus 0 will be 2. 3 minus 2 will be 1. 2 plus minus minus 2 minus 2 will be 0. This 2 and this 2. So 3 minus 1 will be 2. 1 plus 0 will be 1. 3 plus 0 will be 3. 1 plus 2. 1 plus 2 will be 3. And 2 negative 1 will be 1. So this is the answer of part 5. Part 2, 4 and 6 we will do here. Similarly 1, 0, 0, 1 as it is. So first you need to simplify these two matrices. Subtraction is there because these are under parentheses. So plus 0 minus 1 will be minus 1. 2 minus 1 will be 1. 3 minus 1, 2. 0 minus 0 is 0. Now add these two. You will get 1 minus 1, 0. 0 plus 1 is 1. 0 plus 2 is 2. 1 plus 0 is 1. Number 4. Order is 3 into 3. Addition is possible. So its answer will be 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, minus 1 plus 2 will be 1, minus 1 plus 2 will be 1, minus 1 plus 2 will be 1. 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5. So this is the answer for this. Next is number 6. So first you need to add these two. So 1 plus 2, 3, 2 plus 1, 3, 0 plus 1, 1, 1 plus 0 is 1. Plus 1, 1, 1, 1. So you will get 3 plus 1 is 4, 4, 1 plus 1, 2, 1 plus 1, 2. So this is the final answer of part 6. Next is question number 5. Question number 5 says, for the matrices A, B and C, verify the following rules. So part 1, you can take the left hand side is A plus C, this one, and here you can write right hand side is C plus A. So first we need to find A plus C. Add A in C. This is A, this is C. A plus C. 1 minus 1 is 0. 2 plus 0 is 2. 3 plus 0 is 3. Similarly, next row, 2 plus 0 is 2. 3 plus minus 2 is 1. And 1 plus 3 will be 4. 1 plus 1, 2. Minus 1 plus 1, 0. 0 plus 2 is 2. This is our A plus C. A plus C. Now let's find C plus A. Minus 1 plus 1, 0. 0 plus 2 is 2. 0 plus 3 is 3. And 0 plus 2 is 2. Minus 2 plus 3 is 1. Similarly, 3 plus 1 will be 4. 1 plus 1, 2. 1 minus 1, 0. And 2 plus 0 is 2. You can see A plus C and C plus A. This one is C plus A. So both are same. 0 here, 0 here, 2 here, 2 here, 3, 3, 2, 2, 1, 4, 1, 4, 2, 0, 2, 2, 0, 2. So both matrices are equal. So this means A plus C is equals to C plus A. Commutative law of addition. By equality of two matrices, matrices are equal if their order is same. Order is also same and corresponding elements are also same. So we have verified. Left hand side is equals to right hand side. Next question. Question number part 4. I am doing some parts. The remainings are same. So 4 is A plus B plus A. So what is A? Let's write A here. A is 1, 2, 3, 2, 3, 1, and 1 minus 1 and 0. What is B plus A? B plus A. You can add both. So 1 plus 1, 2, minus 1 plus 2 is 1, 1 plus 3 is 4, 2 plus 2 is 4, minus 2 plus 3 is 1, 2 plus 1 is 3, 3 plus 1 is 4, 1 minus 1 is 0, 3 plus 0 is 3. So 1 plus 2, now add these two, 3, 2 plus 1 is 3, 3 plus 4, 7, 2 plus 4, 6, 3 plus 1 will be 4, 1 plus 3 is 4, 1, 5, and minus 1 plus 0 is minus 1, 0 plus 3 is 3. This is the answer of left hand side. Now right hand side is 2A plus B. So first you need to multiply 2 with A. 1, 2, 3, 2, 3, 1, 1 minus 1 and 0. And then you need to add B. What is B? B is 1 minus 1, 1, 2 minus 2 and 2, 3, 1 and 3. So once you will multiply 2, 4, 3 times 2, 6, you need to multiply with each element. So you will get this one. Plus this 1 minus 1, 1, 2 minus 2, 2, 3, 1 and 3. So this will be equals to, I am writing here. So 2 plus 1 is 3. 4 minus 1 is 3. 6 plus 1 is 7. 4 plus 2 is 6. 6 minus 2 is 4. 2 plus 2, 4. 2 plus 3, 5. Minus 2 plus 1 is negative 1. So 0 plus 3 is 3. Now you can see both are same. 337, 337. 644, 644. 5 minus 1, 3. 5, negative 1 and 3. So left hand side equals to right hand side. So we have verified this identity also. Question 5, part 5, C minus B plus A. So what is C minus B? C minus B. From C you need to minus B. So minus 1 and minus 1 will be 0. 0 minus 1, when you do minus it will be plus. So 0 minus and minus 1 will be 0 minus minus 1 will be 0 plus 1, which is 1. So write here 1. 0 minus 1 is minus 1. 0 minus 2 is minus 2. Minus 2 plus 2 is 0. 3 minus 2 is 1. 1 minus 3 is minus 2. Minus 1 minus 1, 0. 2 minus 3 is minus 1. Plus A. What is A? 1, 2, 3. 2, 3, 1. 1 minus 1 and 0. So when you add these two, what you will get? 0 plus 1 is 0. 1 plus 2, 3. Minus 1 plus 3 is 2. Minus 2 plus 2 is 0. 0 plus 3 is 3. And 1 plus 1 is 2. Minus 2 plus 1 is minus 1. And minus 1 and minus 1. So this is left hand side. Right hand side is C plus A minus B. So first write C minus 1, 0, 0. 0 minus 2, 3. 1, 1, 2. This is our C plus A minus B. So A minus B, 1 minus 1 is 0. 2 plus 1, when you do minus it will be plus. So 3. 3 minus 1 will be 2. 2 plus 2 minus 2 will be 0. 3 minus 2. So it will be plus 2. It will be 5 here. 1 minus 2 will be minus 1. Remember, we are doing A minus B. So 1 minus 3 is minus 2. Minus 1 is minus 2. 0 minus 3 is minus 3. This is our A minus B. Just add these two now. So now add both. So minus 1 plus 0 will be minus 1. 0 plus 3 is 3. 0 plus 2 is 2. 0 plus 0 is 0. Minus 2 plus 5 is 3. 3 plus minus 1 is 2. 1 minus 2 is minus 1. 1 minus 2 is minus 1. 2 minus 3 will be minus 1. Now see, match all the elements. Here we have 0 and here we have minus 1. 3, 2, 3, 2, same. 0, 3, 2, 0, 3, 2, minus 1, minus 1, minus 1. All elements are same. But we did some mistake because here we have 0 and in the other matrix in the right hand side we have minus 1. Both should be same. So let's check again what we have done. See, this is C minus B. C minus B means minus 1 and minus 1. It should be minus 2 instead of 0. So we have to write here minus 2. So minus 2 plus 1 will be minus 1 here now. So it will be minus 1. Minus 2 plus 1 will be minus 2 plus 1 will be minus 1. So now both matrices are same. So like this you need to check your answer properly. So now we can say left hand side equals to right hand side. So verified. Verified. Next is question number 5, part 7. C minus B minus A. So C minus B. minus 1 and minus 1 will be minus 2. 0 minus 1 and minus 1 will be plus 1. 0 minus 1 will be minus 1. 0 minus 2 will be minus 2. Minus 2. Minus 2, it will become plus 2, which is 0. And 3 minus 2 will be 1. 1 minus 3 is minus 2. 1 minus 1 will be 0. 2 minus 3 is minus 1. So this is our C minus B. Minus A. What is A? A is 1, 2, 3. 2, 3, 1. 1 minus 1 and 0. So now minus 2 and minus 1 will be minus 3. 1 minus 2 will be minus 1. Minus 1 minus 3 will be minus 4. Minus 2 minus 2 minus 4. Negative 4. 0 minus 3 will be minus 3. 1 minus 1 will be 0. Minus 2 minus 1 is minus 3. 0 plus 1 will be 1. And minus 1 plus 0 will be minus 1. Similarly, C minus A. C minus A. Minus 1 will be minus 2. 0 minus 2 is minus 2. 0 minus 3 is minus 3. Negative 2 minus 3 is minus 5. 3 minus 1 will be 2. 1 minus 1 will be 0. 1 plus 1 will be 2. 2 minus 0 is 2. This is C minus A. You can check minus B. What is B here? 1 minus 1 and 1. 2 minus 2, 2. 3, 1, 3. This is equals to minus 2 and minus 1 will be minus 3. Minus 2 and minus plus minus 1. Minus 3 and minus 1 negative 4. Match your answers. Minus 1 minus 3 minus 1 and minus 4. First row is coming same. Minus 2 plus 2. Minus 2 and minus 2 is minus 4. Minus 5 plus 2 will be minus 3. And 2 minus 2 will be 0. This row is also same. 0 minus 3 is minus 3. Here also we have minus 3. So 2 minus 1 will be 1. And 2 minus 3 is minus 1. So both matrices are same. This one and this one. 1 is equals to 2. It means left hand side is equals to right hand side. So we have verified this one also. Next, question number 9. Question number 9 is A plus B minus C. A minus C plus B. So what is A? A is 1, 2, 3. 2, 3, 1. 1 minus 1 and 0. Plus B minus C. B minus C, 1 minus 1 will be plus 1, so it will be 2 here. Minus 1 minus 0 is minus 1. 1 minus 0 is 1. 2 minus 0 is 2. Minus 2 plus 2 will be 0. 2 minus 3 will be minus 1. 3 minus 1 will be 2. 1 minus 1 0. 3 minus 2 will be 1. So what we will get? 1 plus 2 will be 3. 2 minus 1 is 1. 3 plus 1 will be 4. Here 4. 3 plus 0 is 3. 1 minus 1 is 0. 2 plus 1, 3. Minus 1 plus 0 is minus 1. 0 plus 1 is 1. So you can say this is our equation 1. This is our matrix 1. A minus C. So here it will be 2. Minus 1 and minus 1 will be plus 1. So it will be 2. 2 minus 0 will be 2. 3 minus 0 will be 3. 2 minus 0, 2. 3 minus 2 plus 2, it will be 5 because we are doing minus. So 1 minus 3 will be minus 1. 1 minus 1 will be 0. Minus 1 minus 1 minus 2. 0 minus 2 is minus 2. So what is our B plus B? B is 1 minus 1 and 1. 2 minus 2 and 2. 3, 1 and 3. This is our B. Just add these two, so you will get 3, 1, 4. First row is same. 2 plus 2 is 4, 3, and minus 1 plus 2 will be 1. We will check later what happened. 0 plus 3 will be 3, minus 2 plus 1 will be minus 1, and here 1. Why this element is not matching? So check this element again. We are doing A minus C. So 1 minus 3 will be minus 2 here. So here we have minus 2. So minus 2 plus 2 will be 0 here. Now both are same. So 1 is equals to 2. So left hand side is equals to right hand side. Next is part 10. 2a plus 2b. So you need to multiply 2 with a and 2 with b, then you need to add. So when you multiply 2 with a, you will get 2, 4, 6, 4, 6, 2, 2 minus 2 and 0. You need to multiply all elements plus 2b. Now 2 multiply with b. So 2 minus 2, 2, 4 minus 4 and 4, 6, 2 and 6. So 2 plus 2 will be 4, 4 minus 2 will be 2, 6 plus 2 is 8, 8, 6 plus minus 4 will be 2, 2 plus 6, and 2 plus 6, 8, minus 2 plus 2, 0, 0 plus 6 is 6. Forgive me for plus and minus if there is any inconvenience. Now 2 into a plus b, you need to add a and b. So what is a plus b? A plus b, 1 plus 1 is 2, 2 minus 1 is 1, 3 plus 1, 4, 2 plus 2, 4, 3 minus 2 is 1, 1 plus 2 is 3, 4, 0 and 3. Now just multiply these two. So 4, 2 and 8. First row is same. 4 times 2, 8. 2 and 6. Second row also same. 4 times 2 is 8. 0, 3 times 2, 6. Thanks God, this is same. This is 2, this is 1. So we have verified this identity also. Next is question number 6. Question number 6, A and B is given. We need to find, first part is 3a minus 2b. So 3 times a, 3 will multiply with a, scalar multiplication, minus 2, what will be b? B is 0, 7, minus 3 and 8. So 3 times 1 is 3, minus 6, 3 times 3 is 9, 4 times 3 is 12. You need to multiply all entries with 3. Similarly, this one will also multiply. 2 times 0 is 0, 14, minus 6 and 16. Now just subtract both. So we will get finally 3 minus 0 is 3. Minus 6 minus 14 is minus 20. 9 minus plus 6 will be 15. And 12 minus 16 will be negative 4. So this is your answer. Next part 2 is 2A transpose minus 3B transpose. So you know what is A transpose? Interchange rows into columns. So 1 minus 2, 3, 4 row change into column. So it will be 3, 4 column. Minus 3, what is B transpose? 0, 7 right row into column. Minus 3 and 8. Now multiply 2 with each element of A transpose. 2 times 1 is 2, 6 minus 4, 4 times 2 8, negative minus 3, 3 times 0 is 0, 3 times 3 is minus 9, 21, and 8 times 3 is 24. So finally we will get 2 minus 0 is 2, 6 minus plus 9 is 15, minus 4 and minus 21 will be minus 25, and 8 minus 24 will be minus 16. So this one is our answer. So next question 7 is, if A is this, B is. So next is question 7. Question 7 says, if this equals to this one, then find A and B. So we need to find A and B, two constants. So let's see how to solve this one. First of all, 2 will multiply with each element. So we will get 2 times 2 is 4, 4 times 2 8, negative 6, and 2A. Now 3 will multiply with each element. So 3 times 1 is 3, 3 times B will be 3B, 3 times 8 is 24, and minus 12. 4 times 3 is 12, is equals to 7, 10, 18, and 1. This implies not equal sign. Now 4 plus 3, we will add both. 4 plus 3 will be 7, 4 plus 3 will be 7, 8 plus 3B, minus 6 plus 24 will be 18, and 2A minus 12 is equals to 7, 10, 18, and 1. Now you know the definition of equality of two matrices. Two matrices are said to be equal if their order is same, order is 2 by 2, and the corresponding elements must be same. So 7 equals to 7, 8 plus 3B must be equals to 10. So 8 plus 3B equals to 10. 18 equals to 18, and 2A minus 12, 2A minus 12 must be equals to 1. So 3B is equals to 10 minus 8, which will be 2. So B is equals to 2 by 3, divide with 3 on both sides. So we got B. Next, 2A is equals to, bring 12 this side, it will be plus 12. So 1 plus 12 will be 13. So A is equals to 13 over 2, divide 2 on both sides. So these are the values of A and B. Now you can verify also. If you take the value of B here, 2 by 3 here in this equation, so you can see here what will come. It will be 7, 8 plus 3B. What is B? B is 2 by 3. So 3 cancel with 3. 8 plus 2 will be 10. So this is coming equals to 10. 18 here, and then 2A minus 12. 2A, what is the value of A? A is 13 over 2 minus 12. So 2 cancel with 12. 13 minus 12 will be 1, which is same. So like this you can check your answer also to check. Next is question number 8. Question number 8 says that if A equals to this, B equals to this matrix, then verify that A plus B whole transpose equals to A transpose plus B transpose. So first let's find left hand side, which is A plus B transpose. First of all we will find A plus B. A plus B will be 2, 3, 2, and 1. And we need to take its transpose. Its transpose will be equals to interchange rows into column 2, 3, 2, 1. This will be the answer of left hand side. Similarly, we'll solve right hand side. Right hand side is A transpose plus B transpose. So transpose of A will be 1, 2, interchanging rows into columns, 0, 1. B transpose will be 1, 1, 2, 0. Now add these two, so we will get 1 plus 1, 2, 2, 3 and 1, which is same. Both are same, this one and this one. So left hand side is equals to right hand side. So we have verified this one. Next is part 2, A minus B whole transpose. So take left hand side. A minus B whole transpose is equals to A minus B, 1 minus 1, 0, 2 minus 1 is 1, 0 minus 2 is minus 2, 1 minus 0 is 1. So first of all we have taken A minus B, now we will take its transpose. So 0, 1, minus 2 and 1. This is the answer of left hand side. Right hand side is A transpose minus B transpose. So what is A transpose? 1, 2, 0, 1 minus B transpose is 1, 1, 2, 0. So when you do minus 1 is 0, 0 minus 2 is minus 2, 2 minus 1 is 1, 1 minus 0 is 1, which is same as left hand side. So this is say 1, this is 2, matrix 1 is equals to matrix 2, so left hand side is equals to right hand side. So we have verified this identity also. Next part 3, we need to prove that A plus A transpose is symmetric. You know the definition of a matrix to be symmetric. A transpose equals to A means if you take the transpose of A, it will be equals to A. Then A is said to be symmetric matrix. So this is the definition of a symmetric matrix. Here we have to prove that A plus A transpose is symmetric. So it's mean if you take the transpose of A plus A transpose, it should be equals to this one, A plus A transpose. So this is what we have to prove. So we'll take left hand side. Left hand side is A plus A transpose whole transpose. So what is A? A is 1, 2, 0, 1. What is its transpose? A transpose, interchange rows into columns, 1, 2, 0, 1. This is A plus A transpose. We have to take the transpose of both again. So what it will be? 1 plus 1 will be 2, 2 plus 0 will be 2, 0 plus 2 will be 2, 1 plus 1 will be 2. So transpose of this one will be equals to 2, 2, 2, 2, which is same. Or say this is the answer of left hand side, which is equation 1. Now we can find right hand side. Right hand side is A plus A transpose, which is equals to 1, 2. A is 1, 2, 0, 1 plus A transpose is 1, 2, 0, 1. So when you add these two, you will get 2, 2, 2 and 2, which is same as 1. So 1 is equals to 2, left hand side is equals to right hand side, means the transpose of A plus A transpose is equals to A plus A transpose. If the transpose of any matrix is equals to the same matrix, then it's mean it is symmetric. So A plus A transpose is symmetric. Next is part 4. We need to prove that A minus A transpose is skew symmetric. A minus A transpose is skew symmetric. So what is the definition for skew symmetric? If A is a matrix and its transpose and its transpose is equals to negative of A, then A is said to be skew symmetric. Keep this definition in your mind. So now to prove A minus A transpose is skew symmetric, we have to prove the transpose of A minus A transpose is equals to minus A minus A transpose, equals to the same thing which is under the bracket. Now to prove this, take left hand side. So first we will find A minus A transpose, whole transpose. So what is A? A is 1 2 0 1 minus A transpose is 1 2 0 1. We have to take its whole transpose. 1 minus 1 0, 2 minus 1, 2 minus 0 is 2, 0 minus 2 is minus 2, and 1 minus 1 is 0. Now take its transpose, which will be 0 2 minus 2 and 0. I am changing row into column. So this is equation 1, left hand side. Now we need to simplify right hand side, which is minus A transpose. So keep the minus as it is. First find A minus A transpose. So what is A? 1 2 0 1 minus its transpose is 1 2 0 1. Keep it as it is. So minus 1 minus 1 will be 0, 2 minus 1 will be 2, 2 minus 0 will be 2. Here we will get minus 2, 1 minus 1 will be 0. Now multiply minus, so 0 minus into 2 is minus 2 plus 2 and 0. This is our equation 2, which is same as 1. So 1 is equals to 2, left hand side is equals to right hand side. So we can say that A minus A transpose is skew symmetric. Now number 5, B plus, similarly like 3 and 4, we need to prove 5. B plus B transpose is symmetric. To prove this one, that B plus B transpose is symmetric, we have to show that B plus B transpose whole transpose is equals to this, B plus B transpose. So we will take left hand side first. Left hand side is B plus B transpose whole transpose. So what is B? B we have 1 1 and 2 0. What will be its transpose? Its transpose will be 1 1 2 0. So we have to take whole transpose of both. So when you add, you will get 2 3 3 and 0. So what will be its transpose? Its transpose will be equals to 2 3 3 0. Interchanging rows into columns. So this is equation 1. Now what is right hand side? Right hand side is B plus B transpose. So what is B? B is 1 1 2 0. And what is its transpose? Its transpose will be equals to 1 1 2 0. Now just add 1 plus 1 is 2, 3, 2 plus 1 is 3, and 0 plus 0 is 0. You can see 1 and 2 both are same. 1 is equals to 2. So we can say left hand side is equals to right hand side. And we have established the relation that B plus B transpose is symmetric. Next, last part, question number 8, sixth part is we need to prove that B minus B transpose is skew symmetric. To prove this, we need to show that the transpose transpose of B minus B transpose is equals to negative B minus B transpose, negative of this one, which is inside the transpose. So to prove this, we have to take left hand side first, B minus B transpose whole transpose. First we will simplify this one. What is B1120 minus, what is its transpose? 1120. By interchanging the rows into columns, we have to take whole transpose later on. So 1 minus 1 0, 1 minus 2 is minus 1, 2 minus 1 is 1, 0 minus 0 is 0. We have to take the transpose of this one, 0 minus 1 1 and 0. This is our left hand side, say it's 1. Now let's take right hand side. Right hand side is negative B minus B transpose. So keep the negative as it is. First write B1120 minus B transpose is transpose will be 1120. So 1 minus 1 will be 0, 1 minus 2 will be minus 1, 2 minus 1 will be 1 and 0 minus 1 will be 0. Now this minus sign will change the sign of all the elements inside the matrix. So 0, it will be plus 1, minus 1 and 0, which is same as equation 1. You can see 0 0 1 1 minus 1 and 0 0. So 1 equals to 2. Its mean B minus B transpose is skew symmetric. So okay guys, hope you understand all. Thank you very much. Have a nice day. See you in the next class, inshallah.